Okay, back again. Yeah, very turbulent times. Our crazy guy from the United States just yesterday announced again something totally different. Um, Maybe it is a hopeful sign because it might be possible that the financial markets have shown this crazy game guy a little bit what could happen if he goes further like this, and not especially the downturn of the Wall Street, because this I think was quite anticipated. And there, if you take his statements after the first announcement of the tax and the downward sloping of the Wall Street, he just said, well, this is the price we have to pay, and we are the strongest, and we will be back even stronger afterwards. But what we then, and this is then further, I think in the end of this lecture, we will talk about this. What we also saw at the financial markets, that government bonds of the United States were sold out. So the United States had to pay in the last days much higher interest rates for their debt. And this is, so to speak, a new situation for the United States, because the United States, especially in turbulent times, then they are something like a secure harbor, because you just think, where should I put my money? If the world is going crazy, well, I put it to the strongest and largest economy in the world. And in this time now, the investors just withdraw the money of the from the United States. Pardon? Yeah, gold, but gold is right now not that relevant for Mr. Trump, but it is the government bonds, and maybe this, because there somehow the financial markets have shown him what could happen. But anyway, it's now 90 days. Maybe tomorrow has turned his mind and again is doing something crazy. Well, very interesting times, so to speak. But let's go to our content, because we are just in the model, the so-called neoclassical trade theory, that we started to describe the so-called Heckscher-Ohlin model, where we in general look at two countries. They are producing two goods. These two countries are quite similar, so you can think of these are two similar developed countries. Actually, you can think of the one region is the United States, the other region is the Eurozone or the European Union. So, well, also the standard of living in both countries is quite the same. And therefore, in general, we say that automobiles are quite the same manufactured in the United States or in Europe. And therefore, we assume that we have identical production technology, and also that we have identical preferences. So the demand side is also identical. Of course, that there happens something when they start to trade. There has to be some difference, and the difference should be that they have a different endowment in relative capital versus labor. So one country is capital intensive, the other is labor intensive, and the two goods, although we are producing them, with the same, we are producing them with the same kind of production function in the two countries. Of course, the production of the two goods is different, and there we also assume that A should be capital intensive produced, and the good B should be labor intensively produced. Yeah, from this then we, and also this very important constant returns to scale and neoclassical positive but decreasing marginal products assumption about the production. Neoclassical fully competitive markets. In the end, we have zero profits. These were all our assumptions, and from these assumptions, we at first just start to derive properties. How is a country at first alone under autarky producing for itself, and how much do they sell? So similar to the analysis of the specific factors model, there we also at first derived the equilibrium of autarky. And for this, at first, we derived the dependence that the relative prices of inputs are an increasing function of the relative amount of input, and that since A is capital intensive, that given some price ratio, we can produce then more A than B, or it is used more capital for the production of A than in B, since A is capital intensive, so both are increasing, but the curve of B is just above of the curve of A. Then we ask ourselves, well, when I start to increase the production of A, then I have to decrease the production of B, since I am restricted to my resource constraint. So if one worker switches from one sector to the other, or if I switch capital from one sector to the other, then of course with this capital I cannot produce the other good anymore, and therefore we have to reduce it. And this analysis we found in the so-called Edgeworth box, and we ask for, so to speak, efficient production. We have positive positive marginal product. The more is the better. This means we will use our total resources, and what would be then the optimal division of our resources. And there we found it similar to utility theory, that we said, well, given the production of one good, this we can represent by such an isoquant. And then we ask ourselves how much, also represented by the isoquant of A, how much can we then at maximum produce given the production of the other good. And this just meant we move, given the isoquant of B, the isoquant of A as far outside as possible. Well, and this is then something similar you had done in microeconomics, where you had your budget line as restriction and you moved your utility indifference curve as far outside, and then you had this tangent point, and this tangent point we have here then also. But of course, this thought experiment we have to do for all possible production levels of the other good. So given we're producing two units of B would be maybe this one, and producing 8 units of B would be maybe here the green one. And then always we move the indifference curve of good A as far as possible outside to the upper right. And so we, within these resource box, or Edgeworth box, named after a British economist, we find then a locus of many possible division of the division of our resources producing A and B under the with the assumption it is always the maximum production given the other good. And this is then this so-called contract curve. And then we can say within these points we have always a division between A and B. Here let's say again, this was the indifference curve for B with units 2, and the maximum amount is then maybe for good A. So every point defines us then an efficient production basket of A and B. And this we can then translate again in our already known transformation curve that we just say, well, this point, maybe since we're using many resources for B, that we have a large amount of B and not that large amount of A. And this we do for every point, and then in the end we obtain again such a falling dependence between B and A, and the slope of this, the marginal rate of transformation, again means how much do I have to reduce B if I want an additional unit of A. And we have to admit, this transformation curve in general, we can only derive that it would be a falling curve, that increasing one good, we have to decrease the other good. But that is really concave. This follows from our assumption of constant returns to scale. Maybe we do it in an exercise. I will see that we show it because it is quite hard to show this. Okay. So, and then having these production possibilities, then I said, well, we are in a fully competitive market. This means when we are selling our products, the price of these products, we have to take as given. So then we can ask ourselves, given the relative price, PA over PB, this defines us a possible income. Because income, where have I written it down here? Income is just price A times quantity A, price B times quantity B. So, and PA over PB just defines us the slope of this income line. And then, again, similar to microeconomics, and this is always what we have to think in economics. We almost always think of maximizing or minimizing or in general optimizing something given some constraints, resource constraints, time constraints, anything. So our constraint is now this transformation curve here. These are all efficient possibilities to divide our resources between the production of A and B. The income line looks the same as in microeconomics, the budget line. But now the income line is, so to speak, our aim. This we want to move as far outward as possible, given the production possibilities via the transformation curve. And again, we have this general argumentation that the income line in the optimum, in the optimal production point, has to be tangent on the transformation curve. So we end up just here. Okay, and then we have also modeled in this case our demand, and then we can really one-to-one take our view from microeconomics. Because now we can say, given our price ratio, PA over PB, now also having the income defined, because we are going through this point here. So in the end, we cut here at E over PA, and up here we cut at E over PB. These are our real incomes. Hopefully you remember these cutting points also you have done in your introductory courses. So given income, given prices, we are maximizing our utility. Utility here in yellow, or no, it's red, represented by the indifference curve. We want to move the indifference curve as far as possible outward, and of course this is then under autarky the same point as the production, because under autarky we can only consume what we have produced by our own. Let's see what the people in the United States will say when in 3 years they only can produce their own things, if they are happier than before. Let's see. Or we can interpret this from our classical demand and supply picture that we have derived. Okay, the green curve, given our price ratio, we have, of course, some relative production point, A over B. And if we now increase this price ratio, so to speak, you can also think of, well, I'm fixing the denominator PB and increasing PA. If I increase PA, then it's more favorable to produce A since I can sell it for a higher price. So increasing PA over PB means then also that A over B is increased. Well, very surprisingly, this is just our demand, our supply function increasing, so to speak, in prices. And the same argumentation we can make from the demand side. Utility maximization, the red line, we obtain the falling demand curve. Well, and of course, this point here, A over B, coincides then with this A prime over this amount B prime. Okay, this was what we had, but right now we are just alone. And now we want to start trade. And for this, again, let's put it now a little bit larger, A, B, and A. And due to our resources, the one country should be capital intensive, the other one should be labor intensive. It is also clear that there is one country which can, so to speak, produce relatively more A. Because A is capital intensive, I am the country which is in the resource endowment capital intensive. This also means that I can produce relatively more A. So in one country, the transformation curve, which is in favor of producing A, maybe it looks like this. And the other country, it's just the other way around, relatively more B. So maybe this curve then looks like this. So this would be then country 1, and this 2, since we defined country 1 is capital intensive and country B is labor intensive. Well, actually, they do not have to have the same sizes. Everything applies also or applies only on the ratios. So, but then I cannot draw it nicely. It could be also the case that 2 looks like this. Yeah, you only have to have here the relative shape of this curve, that B over A is larger in one country and A over B is larger in the other country. Okay, but I will skip this, that we are not puzzled with this. So both countries do not have to have the same size. Yeah, because here roughly economically they have the same size. Well, and then let's say we have some optimal points under autarky in country 1 it's maybe this. And in country A, let's say we somewhere here. These are the points under autarky. So now we have to, so to speak, the same situation as in the Ricardian model. We have the difference in the price ratios in the two countries. One good is relatively, so this would be PA over PB in country 1, and this P, let me put it inside because I have to draw something more, PA over PB in country 2. So of course, here we see good A is relatively more expensive than in country 2 because the slope is much steeper than in country 1. Well, now we can say, okay, they start to exchange the same thinking as in the Ricardian model. I can sell my one product for a higher price. The other country wants to pay for it, and the other way around. So they will then, in a trade equilibrium, find some price ratio PA over PB, which is just in between our starting price ratios under autarky. And this means the price ratio, the new price ratio under trade, is then a little bit flatter than the one from country 2, and it will be steeper relative to country, this is 2. It will be flatter compared to the autarky price ratio of country 2 and steeper relative to the price level of price ratio of country 1. Let's do this again in red. Well, and then, given these price ratios, we again look where is then this new income line separately for both countries tangent on their transformation curve. And if I take, that is really a flat line, let's take again just this one. Oops. So this line, new line on trade, has now to be flatter than this one, and it has to be steeper than this one. But then it has to be the same for both countries. So let's say this one. This one is steeper than in country 1 and flatter than in country 2. Okay, what happens? I move here, tangent, and still the same slope. I move here, tangent. Let's take it a little bit steeper because the points are quite in the neighborhood. Let's take it like this. And this one, again a little bit steeper. It is only that I can draw it better, that you see afterwards a little bit more. So this, and yeah, this seems better. So, and let's then, so these are now our new optimal production points relative to the starting. Okay, and then we can ask ourselves, where do I consume? And this is then the same argumentation we had in the specific factors model. Now, production point and consumption point has not to coincide anymore. And this is what Mr. Trumbull hasn't understood. He said, well, everybody should produce in the United States. We shall produce our own goods. But the benefit of trade is in the very general that I do not have to produce anymore only the things I can consume. That these 2 points, consumption point and production point, falls apart. This is the classical win-win situation for both. So, and then we said, well, let's say more is always better for our preferences. So we have then to be in this little triangle. With this little triangle we can improve, since for the starting situation we can consume more of A and B in country 1. So let's assume that maybe we are at that point here, and also here. There we would be in this case, and oops, no, am I right? I have to be here. This is production point, and yeah, let's say we are just here, and this means now this amount is, I'm producing that much A, I'm consuming less than I'm producing. So this would be the export of A, and hopefully it almost coincides. It is hard to draw it by hand, but in general you should then see this, that this should then coincide almost, that you have also here the export. Well, it is quite hard to draw it right in with the no, not the imports. This one is then I am producing only this, and this would be then our imports of A, and the other way around would be that I am exporting good B, and this almost coincides by hand with the imports of B here. If I have drawn it better, then the two the lines has to be, of course, to coincide, but it is hard to draw it just by hand. But I think you know what I'm talking about here. Now, production point in trade of good 2, and this is consumption point. Trade 2, and this is production point, trade of country 1, and consumption point, trade of country 2. Well, and so to speak, here we also directly see that we have an overall benefit of trade because the consumption possibilities of both countries have not only the possibilities have increased, then even our demand for or our equilibrium is then larger than before for A and B in both countries compared to the situation of autarky. Okay, question? Which country? Oh, this one. Yeah, thank you. This is also one. Thank you. Okay, so this is then, so to speak, the end situation under overall trade. And what we now want to talk about is about the so-called core theorems of this trade model, because now we want to look more deeply into the model, what happens to prices and what happens to production, what is relatively shifting when I'm opening for trade. So we take, so to speak, now the result and compare now what has changed compared to the situation under autarky. And the first one is a very important one. This is the so-called factor price equalization theorem. Because what we, from the other picture, from the former slide, only see directly is, okay, the output prices coincide. Of course, we are trading with the same prices since we are trading. But what does it mean for the factor prices? Since we have assumed that production factors are immobile. The worker cannot move from one country to the other country. Have they still different wages or not? So, and here is the maybe somehow surprising result that not only by trade the output prices will equalize. Of course, when I'm trading, then I exchange with the same prices, but that this, due to our assumptions, means also that the factor prices have to coincide. That also wages in both countries and interest rates will be the same. And, well, or the relative, of course, due to, so to speak, exchange rate 200 over 100 is the same as 2 over 1. So, and this is called the factor price equalization theorem. If two countries are engaged in free trade, have identical technologies, produce both goods, then they have then they must have the same factor prices. Here, this is also important. Remember the Ricardian model when we had here BA and the aggregated transformation curve, then of course it could be also possible that in the end, due to preferences, the optimal point wouldn't be in the kink, but here, because overall both societies want even more than in the kink of good A. Preferences are free, it could be possible, and this would then mean that the country which has the comparative advantage in product A is at their capacity limit. And then also the country with the not the comparative advantage has to produce the left amount to come to this. And this we also have to assume here, and this is meant still both countries are producing A and B. No country is fully specialized in one, what also could happen. But then the prices would not coincide is, I think, also intuitively quite clear if one country is at the capacity limit. Okay, this we also, so no country is at the capacity limit. So why is this? Well, let's firstly draw again our adverse box. There we had our contract curve, B and A. This would be country 1. This would be country 2. B and A, K, L, K, L. In exams, I always say, well, you have to really write down what your diagram is meaning, so I have to do it too. So this translates in these two transformation curves, B and A, country 1, country 2. And then in the end, we have this situation here. Production point, consumption point. So of course here we have PA over PB of 1 is also PA over PB of country 2. But, and this we have done last week, we had derived, where did I have it? I have written it down when I really remember it. Yeah, that the price ratio of the output prices via my profit maximization in the country, I'm still doing profit maximization in my country, means since I have constant returns to scale, so these, where did I have it here? These constant input ratio, that this then means, given the price ratio, this pins down the wage interest ratio also at a specific level. And this, we can then take that, of course, this pins down W over R1 and W over R2, and so we can deduce that also WR over 1 has to equal W over R2. This comes directly, this we obtain directly from profit maximization and again these constant returns to scale. So, and this is a quite nice result, since although we have totally immobile factors, international trade is, so to speak, a substitute for mobility in factors. Because, of course, if factors would be mobile, then, of course, just from the equilibrium process, we would say if the wage in one country is higher than the wage in the other country, everybody moves over there. And this was the assumption always in the specific factors in the Ricardian model, the two sectors. If the factor is mobile, then the price of the factor has to coincide. Here we said the factors are not mobile, but in the end I trade the output, and that this has the backward implication that nevertheless also the factor prices has to coincide. So trade is a substitute to mobility of factors. If factors would be mobile, then we would directly have that they have the same prices. Okay, then the second one is the so-called Rybczynski theorem, and this states that let's assume we have given good prices, so PA over PB, let's say some level PA over PB prime, and we increase the endowment of one factor. Let's say we are increasing capital. What happens? How do then the production in this country is shifted when we obtain capital somewhere from outside, or you find some new resources in your country? That if we increase one factor, that then this industry which is using this factor relatively more intense, that they will increase their production. I think this is also intuitively quite clear, but let's see how we can directly this derive from our model. And for this, yep. Yeah, but again in this relative context. Yeah, yep. So again, let's start with our Edgeworth box, B and A, labor, or did we have always labor capital? I should not mix this. Capital labor we had, I think. Capital labor always. Because in some textbooks you find, then you have to be careful. In some textbooks it's just interchanged. And then sometimes an increasing function you have seen by in my lectures is decreasing. There you have to be a little bit careful. Okay, so but this way around, capital and labor. Okay, then because then I can draw it easier. So again, what does it mean here? Within this Edgeworth box, we have found that we have our contract curve. We also know, let's go at this diagram here, that given the prices, and we have learned given output prices also pins down our factor prices. So given the factor prices here, represented by the slope, means constant returns to scale, that capital over labor is constant for both goods. For the capital intensive good it is larger, for the labor intensive good K over L is smaller. Okay, so with this we can then go into our Edgeworth box, and this means A is capital intensive, so this line has to be steep. This is the profit maximizing possible production of A given the prices, and we have a flatter one for B, but now this flatter one we are drawing not from this origin but from this, and flatter one means it has to go up. Okay, so and of course then the cut of these two lines is our optimal production point given our labor amount and given our capital amount. And now suppose L bar, we obtain, as we have done it in Germany in the 60s, we went to Italy, and in the 17s we went to Turkey and asked, please come to our country because we need you. We have more work than we have people. So suppose increase of L bar. What does it mean here in our picture? Well, this L bar is increasing. So this means I just have to draw a larger Edgeworth box. I just increase this amount here to, let's say, of L from L bar to L bar prime. L bar prime is larger, is maybe up to here. This would be L bar prime. Then, of course, K bar hasn't changed. It is still like this. Now it starts from here. Now this is the origin of B. The production technology has not changed. So this line is still the same. There has nothing changed. But I have to take now a parallel line from the old origin of B, starting from the new origin of B. And then, of course, hopefully I make it to draw it somehow parallel. This would be now the new possible cost minimization production line of product B. We have a new cut of our two products A and B. Maybe I should write it down here. This is A and this was B, and this is now B prime. And of course, what do we have? This is now our much larger length. This means that the represented isoquant here for B prime has to represent a much larger amount than this shorter line. Okay, so I see here then B is increasing and A, of course, from this point to this point here, A is decreasing. Well, I think this outcome is not very surprising. This we can also quite intuitively argue, but here we can at least graphically show it directly in our diagram. Okay. Another one, and this is the so-called Heckscher-Ohlin theorem. Well, a country exports the good which it is using with the abundant factor intensively. Remember, country 1 is capital intensive in the factor endowment, has relatively more capital than the other, and good A is capital intensive produced. So from our model should come out that country 1 is exporting good A, and the other way around with trade, country B is exporting good B. Well, there last week we had derived the dependence, supply and demand. About this we have also talked in the beginning today. This is this picture here. This was the situation under autarky, and here now we want to argue what happens to the supply curve when we are opening for trade. So this was the situation under autarky. Let's say this is the country 1. We had assumed identical demand, so we have only one demand curve when we are moving together. Nothing changes with the demand curve. So if we assume that this is country A, so at this price level of PA over PB in country 1, we have already argued, remember this here, that the slope of the autarky equilibrium in country 1 is lower than the slope of the autarky level in country 2. So what does it mean? This just means, the supply curve of country 2, or let's say this is supply curve of country 1, since the price level under autarky, since they are labor intensive, they are producing relatively more B, A over B in equilibrium has to be smaller than A over B in country 1 because they, so to speak, love to produce with labor. This would be the price level under autarky in country 2. And then we argued, okay, moving together, trade, that we have in the end then with trade a new, let's say, world relative price level in between the starting two price levels. Well, our supply curves, of course, haven't changed, and then this means I'm country 2 is exporting A, moving from this here in the middle, I'm producing more A than I consume. This we also have already seen in this overall diagram. Sorry, country 2 is country 2. We are coming from here. Sorry, is exporting B, and country 1 is exporting A. This we have also already seen in this picture, where we also said, well, we have here our production point, and this was the amount. Then due to the higher relative price of A now, we are increasing production of A and we are selling for a higher price, since we are capital intensive. Okay, And then the last one, half an hour, hopefully I make it, because this is then the quite famous Stolper-Samuelson theorem. And yeah, this was found in the 1940s, and I have to admit, here we cannot anymore directly see it drawing some curves and so on. If you look at many textbooks, then you more or less find only one diagram, and then more or less only it is stated. This is the theorem, and it is not really explained, because now we have to go a bit deeper although in the mathematics, especially in the property of constant returns to scale production technology. Okay, what does this theory means? It means an increase in relative price of a good will increase the real return of the factor used intensively in the production of that good. So this is maybe not at least somehow still we can argue via a diagram, because this would mean if we are starting, let's say here, now showing the dependence between relative prices and relative input prices. We have already argued there's a one-to-one dependence, but we have not talked about the direction of this dependence right now. Let's say we start at some level, PA over PB prime, and that we now decrease PA over PB. So A becomes now relatively cheaper compared to B, and here we have the wage rental ratio. So the price of capital is in the denominator. We dividing with the price of capital. The good A, which is capital intensive produced, remember? Remember, A is capital intensive. Then we would expect that a decrease of the price ratio of A, so to speak intuitively, it is harder to sell A. And what could be the reason? That the cost of production of A has also increased. So that the price of capital, which we use intensively for the production of A, has also increased. So this is, so to speak, the intuition that then for a decrease PA over PB to PA over PB double prime, which should be smaller than PA over PB prime, PA over PB double prime, that this then corresponds to a to a larger ratio of wages over interest, since the interest has now shit, increased. So let's see how we can argue this also from our other diagram. There we can say, okay, again, we say our production in this capital labor diagram, how did we obtain it? Well, the ratio of W over R is again the slope of our cost line. And given this cost line, we had our efficient production of A and B. And if we now decrease what we have assumed here, PA over PB, since we have this direct correspondence between output prices and input prices, then also A over B has to increase. And this means that the slope of our cost has to be steeper. That if we still producing the same amount of A, this means producing still the same amount of A. We have to be now, let's do it in red, again tangent on the isoquant of A, means producing still the same amount of E of A, the new tangent of the isoquant of A has to be steeper. And this means that the new isoquant B prime has also to move inside. And this means the new isoquant of B has to move to the left. So, but moving with the isoquant to the left, what does it mean for the amount compared to the starting amount when I'm moving to the left? And this is the same as in the utility theory. On the left, I have less. So then B prime smaller than my starting B, and this then of course means that sorry, this was written wrong. This has to decrease. Oops. That now the ratio of A over B, I have still the same number of A, and I'm now dividing by a smaller number B, and therefore it has to be smaller, and of course the slope V W over R prime is now, since we have a steeper one, larger than my starting slope, and so in the end I obtain this falling dependence here. So overall, this means at first the relative argumentation, if PA over PB is increasing, then the relative output input prices are decreasing. Well, but the theorem says something more, and this is now the hard part, that the real return of one factor is increasing in terms of both goods. Remember what we have argued in the specific factors model? When we have opened for trade, then we have argued, okay, wages are increasing, and then we asked, are the workers better off? And you remember we have said, well, wages have increased, price of there, it was also, I think, it was industrial good, has increased, but the price of the agricultural goods was still the same. So I could afford now buying more agricultural goods, but we have argued that the increase of the industry good was larger than the increase of the wage. And therefore we said, well, it's ambiguous. We don't know if they are better off, because if they want to buy, if they favor the industry goods, they can now buy less than of the industry goods. And here in this statement, it is meant that the increase has the same effect measured in both goods. Well, and how can we show this? Now it's 15 minutes left. Hopefully we make this. So then let's move into the dependence of what we have also already derived of input ratio versus factor input prices. This was more or less the first diagram which we had derived in this model. This was this one here. Okay. Oh, well, I have now interchanged the axis, so A is now the upper curve. So there we had the dependence K over L A and K over L B. So in the end, we have already PA over PB is increasing, then W over R is decreasing. So let's say we start from this point here and we move inward after so this is the starting point. And since W over R is decreasing, we are moving to the left. So this means then, due to this dependence, K over L is decreasing in both sectors. But what we know, and now comes the mathematical part, we have in general production of K and L with constant returns to scale means, remember, doubling output means doubling input. So what we now do is we just move this amount of labor outside of our function. This is, so to speak, we had constant returns to scale. Remember, we had just said lambda f of K and L equals f of lambda L K and lambda L. So to speak, if we only look at f of K and L, this we also can write as f of K times 1, comma L times 1. And then this is somehow some intellectual point. We switch then, and now we assume that our L is our lambda. Yeah? And so to speak, that our 1 is just our variable. Because that is mathematically, it's irrelevant. Economically not, but mathematically. It doesn't matter what we assume, what is the variable and what is the parameter. So we move out the L, then we obtain, this is L outside now, times F. And in order to obtain, when we go back inside, we have to divide K over L, because L times K over L is K again. And on the right side, we are just left with a 1 with a constant. And then let's define K over L as small k, just capital per capita. So since this is a constant, we can interpret this as a new function which is only dependent on the relative capital, because the other one is a constant and we can ignore it. Okay, so this would be then some small f depending on relative capital. We just redefined this. This is defined as capital F over L, comma 1. This is just a definition. So remember, here we have relative capital. Why we are doing this, and we are looking here at the relative capital. And then when we are looking at the production, we are interested in the marginal products. What are the marginal products? The marginal products are just the first derivative of our function. So what we are now doing is marginal product of um, labor and capital, and both are just the derivatives, once with respect to capital and once with respect to labor. So let's start with df over dl. There we have here the labor and here we have labor. They are both multiplied. Which kind of rules, which kind of rule when I take the derivative I have to apply? If you have a function f of x is u of x times v of x, then f prime is you have to use this product rule, and this is then u prime v plus u v prime. So then L with respect to L is just 1. So we are left then with f of k. Then u is L, we have to take it, is L times v prime. This is this prime at first, but what we have to use now is the chain rule, because we have that we have capital F of k over L. So k over L is itself a function of L. And remember, f of g of x, then f prime of g of x is just f prime times g prime. I think you have done this also in your introductory course in mathematics. So at first we have to take the outer derivative. This is f prime of k. And now we have the function f of L equals k over L. What is then f prime? Or let's say you have a function f of x is a over x. What is f prime of x? Okay, sorry. Okay, no problem. So this is just x to the exponent minus 1. Exponent in front of it is minus 1, and you have to decrease the exponent. So this would be a over x squared minus. So times then minus k over L squared. This cancels out, and in the end we obtain f of k minus k times f of k. And the marginal product of k, this is a little bit easier since we find k only here in the relative capital. So we have L f prime of k as the outer derivative. Somehow this function looks like, maybe it's a Cobb-Douglas function or anything else. And then we have to take the derivative now. F of k is k over L, so to speak, 1 over L times k. K with respect to k, the derivative is just 1, so we are left with 1 over L. We obtain the easy dependence that the derivative with respect to capital K is the same as the derivative of the new function with respect to small k. Okay, and now we want to have the dependence of the marginal product. Now, remember, oops, we have in profit optimum, profit maximization, meant that price of A times marginal product of capital of the production of A equals the interest rate. And also PA DFB, sorry, not B, A with respect to L is just wages. This hopefully you have not only seen in my course, but in general that you have the value of the marginal product. Value of marginal product is the output price times your marginal product has to coincide with your input price. What was the intuition behind it? The next guy which I am employing, I have to pay him the wage, and the additional output or the additional revenue which I obtain has to be as large as these additional costs. This is just behind the math you see here. And if the new guy is more expensive than what I can additionally earn, then I won't increase my production. Okay. So, and therefore, I'm interested in the dependence of the marginal product on the relative inputs. So, what is the dependence of marginal products on relative inputs, K over L, which I have defined as small k. Well, the dependence in mathematics, we are always calculating just the derivative. So now we take this, and we calculate the derivative with respect to small k. So this would be then, let's say this is, here we have it. So df dl, and this we take the derivative with respect to small k. Well, and then we have just to look at this here. So this would be f prime of k, then product rule. Oh, here I have somewhere forgot there's a prime coming from this. So k with respect to k is just 1, so minus f prime. And what is left? Minus k times f double prime of k. This cancels out, but what have we also assumed? Neoclassical production function looking like this, f of k. We have a decreasing marginal product. So the slope of the slope will be smaller and smaller and smaller. Yeah? This was this. So we know that this is smaller than 0. K is a positive number together with the minus sign. we obtain here a positive number, a positive dependence of the marginal product on relative capital. What is the dependence of the marginal product of capital with respect to small capital? Well, this is quite easy. It's only the derivative of the derivative. This is just the second derivative. And here we have already argued. The second derivative by its own is just a negative number. So this is smaller than 0. So, and now we have with this and this everything together. Don't be too much confused. Where did we have started? We have started with PA over PB. We are finished in a minute. Is increasing. We have derived then the relative price is decreasing. Moving to the left, K over L is decreasing for both goods. Different amounts, but it is for both goods decreasing. K over L is decreasing. And now this meant, when we call this marginal product of labor and this marginal, or this one, sorry, marginal product of labor and this marginal product of capital, a positive derivative means we have a monotonically increasing function. So marginal product of labor has to increase while marginal product of capital has to decrease. And what we also can say, what is the real rental? This is just R over PR and so in the end, where do I have it? MPK is falling. That since sorry, something is wrong. I have an increase here. Where is my wrong interpretation? This is increasing, this is decreasing. Decreasing capital over A. L is decreasing. Now I'm also a little bit lost. Decreasing, have I put it in the wrong way? No. So this is decreasing, 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 and an increase both goods, marginal product is decreasing, and where am I? Then, oops. Somewhere I have made a little mistake. So increasing, decreasing, capital over A is decreasing, and I have this is positive, this is negative. Somewhere I have missed a sign, I think. So since we are already 5 minutes over time, I have to look it up at home where I have missed my sign, because the effect should be the other way around. I have to look it up, and next week we will also go through it with an example where we do all the math in parallel, that you really see it, yeah, from this one. So there we do it in a mathematical way with production functions anyway, and then I will explain it to you. Okay, so then we stop for here today. Thank you. I know that was a bit hard stuff today, but this is maybe something like the crown of international trade theory. Okay, thank you.